Hello class, today we're going to be learning lesson 5-2 in our algebra books, which is all about solving inequalities using multiplication and division. We did this yesterday with addition and subtraction, so what I'd like us to remember is that solving inequalities is just like solving equations. Your goal is to get the variable by itself. So let's recall a very simple one-step equation that we may have had before, x divided by 4 equal to 5. The way that we solved this was by multiplying the number 4 on both sides because we saw the variable was being divided by 4, so we wanted to do the opposite operation of division, which is multiplication. And when we multiply both sides by 4, on the left-hand side the 4's cross out, and we're simply left with x on the left, and the right side, the 5 times the 4, turns into 20. And we're done with that. So let's practice the same thing if I have x divided by 4, but this time I have the inequality, the less than symbol is less than 5. We're going to do the same process. We want to get the variable by itself. So multiply both sides by 4, because I do see that the variable is being divided by 4. The 4's will cancel each other out, because 4 divided by 4 is 1. So I'm left with x is less than 5 times 4 is 20. So it's the same thing that I got up above, the 5 times the 4, except instead of an equal sign, it's less than, which means the solution for this inequality is any number that's less than 20. So when I graph this on my number line, I'm going to put in just a few things here. 10, 20, 30, negative 10, negative 20. And because it is just less than, it's not going to be equal to 20, so it's going to be an open circle on 20. And it's all the numbers that are less than 20, which means the direction to the left. So I'm going to draw my arrow. I'm going to shade all of these values because any of those can be solutions for that inequality. Make my arrow really big on the left-hand side. So let's do another one. Let's say for our next example that we have 2 is less than or equal to m divided by 3. Now this time the variable is on the right-hand side, but we're going to do the same thing. We want to get that m by itself, so I'm going to multiply both sides by 3. The 3's cancel out, and 3 times 2 is 6, so 6 is less than the value of m. But I do want to practice rewriting this so that the variable is always on the left-hand side. So when I do that, I'm going to put the m first, and the variable, the inequality is going to switch. So instead of it being less than or equal to, it's going to be greater than or equal to 6. And this is going to be much easier now to graph on a number line. 0, 3, 6, negative 3, negative 6. And because the solution can be any number that is greater than or equal to 6, it can be equal to 6, but it's also any of those numbers that are greater than 6 as well. So I'm going to shade going to the right-hand side. Now things are going to change a little bit when we have negative numbers thrown in, and it's only going to change if you're multiplying both sides by a negative number. So let's say I have y divided by negative 6 is greater than the number 7. Okay? The rule is that when you are multiplying both sides by a negative number, you're actually going to have to flip the inequality. So you see that there? I flipped the inequality that used to be greater than, now it is less than. Okay? And so that's very important because for your solution, when you're graphing it on your number line, you want to make sure that you're graphing the correct direction. So negative 42 is about right here, and it's going to be an open circle, and it's all those values that are less than negative 42. So does that make sense? So what we're going to write down is when you multiply both sides of an inequality by a negative number, you must flip the inequality. Okay, so this is very important for you to remember whenever you're going to be doing this with negative numbers. And again, it's only when you're multiplying both sides by a negative number. So let's move on to division, which is very similar to multiplication. Before, you may have had something that looked like this. 5v is equal to 45. All right, and when you wanted to isolate the variable to solve for it, you would have divided by 5 on both sides. Since 5 was being multiplied before, now you would divide by 5, and you would get v is equal to 9. You would do the same thing if you have an inequality there. 5v is, let's say, greater than or equal to 45. If you want to get the v by itself, divide both sides by 5. The 5's cancel out, and v is any number that is greater than or equal to 9. Very similar to multiplication, it's one step. We're going to graph it on a number line. And because it can be equal to the number 9, I am going to fill it in. And it's any number that is bigger than or equal to 9. We say greater than. Any number that's larger or equal to 9. Okay, let's do another one. This is 24 is greater than 8p. You'll notice again that the variable is on the right-hand side, so we'll take care of that at the end. But I do see that it's being multiplied by the number 8. So I'm going to divide both sides by 8. 24 divided by 8 is 3. So 3 is greater than p. But I do want to rewrite it so that the p comes first. And when I do that, I'm going to have to flip my inequality. So now on my number line, I'm going to graph all the solutions p that are less than the number 3. And it is just less than, it's not equal to 3, so it's going to be an open circle. And it's going to be all of the values that are less than 3. So it's going to go in the negative direction to the left. Okay. Now, this is very similar to the rules of multiplying by a negative number. If we have to divide an inequality on both sides by a negative number, it's going to affect the final outcome with the direction of the inequality. So if I have negative 6n is less than 18, I'm going to divide both sides by negative 6 to get the n by itself. But when I do that, I need to flip the inequality. So instead of it being less than, it's going to be greater than negative 3. So like I did before, I'm going to flip my inequality, and now I can easily graph it. Okay, and it is not equal to 3, but it's all the numbers that are, I'm sorry, negative 3. It's all the numbers that are greater than 3, negative 3. So I'm going to shade going to the right. So we should write down, just like we wrote down for multiplication, that when we multiply or divide both sides by a negative number, you must flip the inequality. I think that if you get anything out of this lesson is that you'll remember that only when you're multiplying or dividing both sides by a negative number that you're going to flip the inequality. Okay, you must remember that at the very end. So what I'm going to leave you with are 2 example problems that I'd like you to practice yourself. And let's see if when you come back to class tomorrow, if you have successfully solved and graphed each inequality correctly. And that's it for today.